Methods of expressing solutions. The concentration of a solution is expressed as the amount of solute present in a given amount of the solvent or solution. For example, in a salt solution, concentration of solution equals amount of a salt in a given amount of the solution. If the amount of solute is small, it is called a dilute solution. If the amount of solute is more, it is called a concentrated solution. Let us discuss about solubility of a substance. Solubility of a substance can be defined as the maximum amount of the solute in grams that will dissolve in 100 grams of solvent at a given temperature. It depends upon nature of solvent. A solute may have lower solubility in a certain solvent, but a higher solubility in another solvent. Iodine crystals dissolve slightly in water, but dissolve very well in alcohol. We will now try to understand factors determining solubility of a solute. Solubility depends upon the nature of the solute. For example, at 20 degrees centigrade, solubility of sodium chloride is 38 grams per 100 milliliter of water. Solubility of potassium nitrate is 30 grams per 100 milliliter. Solubility of sodium bicarbonate is 9.6 grams per 100 milliliter. And solubility of copper chloride is 77 grams per 100 milliliter. This means that at 20 degrees centigrade, copper chloride has about twice the solubility of sodium chloride. Solubility also depends upon the temperature of the solution. Generally, solubility of solids in liquid solvents increases with temperature, but the solubility of gases in liquid solvents decreases with temperature. So, we mention temperature while mentioning solubility. Let us now try to understand how temperature affects the rate of dissolution. A given amount of distilled water is poured into two separate beakers labeled as A and B. Water in beaker A is heated till 70 degrees centigrade, and 1 gram salt is added to each beaker. The mixtures are stirred at the same rate. We see that the solid dissolves at a faster rate when heated. Higher the rate of stirring, higher is the rate of dissolution. When particles of one salt are grinded into fine particles and the other remains as it is, we find that finer particles dissolve faster. So, we see that the rate of dissolution depends upon these factors. That is, nature of solute, temperature, rate of stirring, and size of solute particles. Finally, let us see some applications of solubility in our daily life. That is, hot water increases the rate of dissolution of certain substances present in tea leaves. Stirring of soup dissolves the salt faster, and so on. Let us now learn how to express the concentration of a solution. It is normally expressed as mass by mass percent or as volume by volume percent. Let us first learn about expressing concentration in terms of mass by mass percent. Mass by mass percent of a solution may be defined as the number of parts by mass of one component per 100 parts by mass of the solution. If A and B are the two components of a binary solution, then mass percent of A equals WA divided by WA plus WB multiplied by 100. And mass percent of B equals WB divided by WA plus WB multiplied by 100. We will now learn about expressing solutions in terms of volume by volume percent. Volume by volume percent of a solution may be defined as the number of parts by volume of one component, that is solute or solvent, per 100 parts by volume of the solution. Mathematically, it can be written as volume percent of A equals VA divided by VA plus VB multiplied by 100. And volume percent of B equals VB divided by VA plus VB multiplied by 100. The concentration of a solution can also be expressed in terms of the mass of a particular solute dissolved in a given volume of the solution. Mathematically, it can be written as mass by volume percent of solution equals mass of solute divided by volume of solution multiplied by 100. Here is an example for you to understand this concept. A solution is prepared by dissolving 5 grams of urea in 95 grams of water. What is the mass percent of urea in the solution? Now, let us have a look at the solution. Mass percent equals mass of solute divided by mass of solution multiplied by 100. Solution, therefore, is mass of urea equals 5 grams, mass of water 95 grams, mass of solution equals 5 plus 95 equals 100 gram. Mass percent of urea equals 5 grams divided by 100 grams multiplied by 100 equals 5%.